Hi, today the video will be very short. What I'm going to explain in a moment took a while to figure out, so I thought sharing it was useful. As per video title, I'm going to talk about the DS3231 real-time clock. The examples provided in the Adafruit Arduino library and the library reference itself are quite cryptic on how to effectively sync the RTC with the computer on compile time. Yes, you can sync the time using the LostPower method, but removing the RTC battery manually for this is tedious. The simplest solution I found so far is to get a checksum of the sketch, compare it to the one in the board's EEPROM, and if they differ, do the time sync. This was tested with an ESP8266, but it should work with ESP32s and other Arduinos with some changes. So here's how you get the checksum with this method here, get sketch MD5. And then to avoid wearing the small EEPROM out prematurely, you can write a single base 16 integer, like this, which is an 8-bit integer specifically, corresponding to the first two characters of the MD5 hexadecimal checksum. So once you get the checksum here, with this substring here, you get the first two characters, you transform them into a character string, a normal character string. So from an object, it becomes a normal C string. And then, thanks to the strtol function, it becomes a base 16. Here, you see it here, base 16 integer. Okay, so I prepared this C example file, which I called a.c. As you see here, we are using the same function as I used in the sketch. Essentially, we are transforming AA, which if you know A in base 16 corresponds to 10, we're transforming it into an integer. So this first A corresponds to 10 because it's at the position 0. This one is at the position 1. Of course, if you do the math, it becomes like this, right? And here I'm just doing on the operation, so it becomes 170. When we compile that small program, execute it, see? This is what that strtol function do, even in Arduino, not just in plain C. It's the same thing. So of course here in the sketch we get the current checksum, okay? And we also read the existing checksum in the EEPROM. We just compare it, and if it's different, we write the new value to the EEPROM, and we return true. The function, as it's written here, returns a boolean, and when it returns true, it means the sketch was just uploaded. And of course, when the checksum is the same as the one stored in the EEPROM, it returns false. You adjust the time to the compile time only when the sketch was just uploaded, or, as it's written here, when the RTC lost its power. This first condition is the same as in the example sketch, and also this one-liner is the same. I just added this one because every time you upload, right, your sketch, the time will be adjusted. But bear in mind that if you do like this, when you upload your sketch, it takes about a minute or maybe 30 seconds to upload to the board, and so the RTC will not be adjusted exactly to the moment of the sketch compilation, but it will have a slight delay of 30-40 seconds because of the upload time, because the board boots after the upload. So if you want, you could compensate that, but in the sketch, I just you see here, in the sketch, if there is Wi-Fi available, I just run a sync RTC, the sync RTC function, which will use the NTP protocol to update to the correct time, right? So this is the stock example for the DS3231 Adafruit library, the RTC library, RTC lib here. Okay, and if you see here, we have those instructions I told you earlier, but there is no indication on how to do that sync, right? The way I do it. Also, if you open the documentation reference for this library, it's the same thing. It's not really explained how to do it, so you need to do some research, okay? And so as you see here from the file name, this is still the gas detector project, which I updated and fixed this time sync problem, which was present in the previous releases. And so if you want, you can see the previous videos. There's a playlist, and yeah, I think that's it for this video, and thanks for watching, and see you next time. Bye bye.